Okay, here we see that the ladder is placed against the building, and we are told that the bottom of the ladder is slipping away from the base of the building at a rate of 5 feet per second. So, if we say that the distance between the base of the building and the ladder is x, then we can represent this as a dx over dt. That is, this represents the rate at which the bottom of the ladder is slipping away from the base of the building, and so we have represented this as dx over dt. And we have to determine the rate at which the top of the ladder is slipping down from the top, so that we represent as y, because if we represent the side as side ob as y, then the rate at which the top of the ladder is slipping away we can determine as dy over dt. And the first thing that we have to find is at the instant when x equal to 15 feet, we have to determine the corresponding y. So first let's do that. For this, I'm going to consider this as a right triangle, because we see that at the point or at the base of the building, we see that it is a right angle. So this is a right angle triangle. So that means we can use the Pythagorean identity. So let's apply this Pythagorean identity to this triangle. And this says the sum of the squares of the two legs of any right angle is equal to the square of the hypotenuse. So here we have the two legs, that is OA. We have to square it up. And OB is another leg. We have to square it up. And this equals hypotenuse, which is AB. We have to square it up. Now let's plug in the values which we know. We know that x equal to 15 feet. So I'm going to plug in OE equals x, which is 15 squared. And we plug in OB as y. So therefore this is y squared. And this equals AB is 17 feet. So I plug in AB equals 17, and this becomes 17 squared. Now let's calculate y from this one. So first I solve for y squared, and this equals 17 squared minus 15 squared. So we see that y squared equals, let me plug it into the calculator. 17 square is 289, and 15 square is 225. So when we do the subtraction, we get 64. That is y square equals 64. Now we take square root on both sides to determine y. So therefore we get y equals square root of 64 is 8. So we have determined the corresponding y distance when x equal to 15 feet, and this is we can now say that it is 8 feet. Now we are going to once again use the Pythagorean theorem. That is, we when we apply it to the right triangle, we can say that x squared plus y squared, and this equals 17 squared. Now let's differentiate each of the terms by applying the chain rule. So differentiation of x squared with respect to x is 2x, plus differentiation of y squared is 2y, and then we have to differentiate y, which is dy by dx, and this equals 0, because differentiation of 17 square is 0. I just forgot to put this dx over dt here, because the differentiation of x squared with respect to x is 2x, and when we do the chain rule we have to put dx over dt, and this is also dy over dt. Since it is changing with respect to time, we should put dy over dt and not dy by dx. So we are differentiating both sides with respect to time. So now we can see that we can cancel this 2. We divide all the terms by 2. So we are left with x times of dx over dt plus y times of dy over dt, and this equals 0. Now let's plug in the values. We know that x equal to 15 feet, so I plug in x equal to 15, and we are also given dx over dt, which is 5 feet. So I plug in 5 feet for dx over dt. We found the y, which is 8, and then dy by dt. This is the thing that we have to solve. This equals 0. Now we have to solve for dy by dt. So I keep this 8 times of dy by dt on this side and push this product. This is 15 times 5 is 75. So we will have positive 75. So when we subtract 75, we will have negative 75. Now we can solve for dy by dt by dividing both sides by 8. So we get dy by dt, this equals negative 75 divided by 8. And this is negative 9.375. And this unit is feet per second. So we see that the top of the ladder is slipping at a rate of 9.375 feet per second. This negative indicates that it is slipping down, it is not moving up. So we can say that in terms of rate, the rate at which the ladder top of ladder is slipping down, and this equals 9.375 feet per second.